right, so number 34 from the homework from last night. I've got a right triangle, two sides are given. How can I find the third side? How can I find the third side, folks? Pythagorean theorem. Okay. The side that's missing is the hypotenuse, and it is, I'm just going to call it x. The legs given, root 5 squared. I'm listening. No, you need to do each of them separately.
I meant like okay, first day.
You figured out the square root of 5, and then you squared it.
Right.
Yeah.
And then I figured out the square root.
Yeah. But what happens when you square a square root? It's like it's undoing each other, right? So you actually end up with x squared is equal to 5 plus 2, which means 7. What do I do to solve for x? Square root of both sides. Do I know the square root of 7 without a calculator? No. Leave it. That's simplified. Root 7. Okay? Did I give you all that number? No, I gave you approximately 265. No. In my opinion, if you are given two sides that are in radical form, then I would leave my third side in radical form. Does that make sense to you? Okay. So I would leave it as the square root of 7. And it is 265. Okay? And then we've got to find an angle. Which angle do you want to find? And it doesn't matter. You can find D or F. I heard both of them. I'm going to find D. Okay? Here we go. Angle D. With respect to angle D, I've got my hypotenuse. I have the opposite and I have the adjacent, correct? What if I would have gotten the square root of 7 wrong? If I get it wrong and I use the hypotenuse to solve for angle D, then I'm going to get angle D wrong. So my suggestion is this. The original information was the opposite and the adjacent, which means I'm going to use which trig ratio? I'm going to use tangent, okay? So I'm going to have tangent of angle D, which is approximately root 2 over root 5. How do I find the angle measure? That's right, I find the inverse tangent. Root 2 divided by root 5. Okay? So calculator, which is going to be inverse tangent, I'm going to do square root of 2, closing the 2, closing the square root, divided by the denominator, square root of 5, closing the 5, closing the square root, approximately 32.3. Is that what I said?
Yeah.
32. And the instructions say round the angle measures to the nearest degree. So if I round 32.3 to the nearest degree, it's going to be approximately 32 degrees. And check this out. If this is 32 degrees, there we go, 180 minus 90 minus 32, which is 48 degrees. Because that's 7 and 10 is 80. Okay? So it's angle F. Pardon me? 48. 48. Yes. Yeah. Questions at all? None? Good. I want you to see this. Thank you, Daniel. This should be 58, not 48. 58. Daniel's right. Because that's 90. 90 is 180. I was trying to get to 80 and not 90. So it's 58, folks. It's F. Oh, I don't care. I make mistakes all the time. Thank you, though, for calling that. We are going to continue on this right triangle stuff, the trig ratios, and we are dealing with angles of elevation and depression above the line, okay? Because this is going along with right triangles. Everything we need to do with right triangles. An angle of, do you think it's going to be elevation or depression if something is above the line? Elevation. So an angle of elevation is from the line of sight up. Now, if I'm standing right here and I'm looking at that, what am I looking straight at? What on the door, though? The 132. Right now, if I stare right forward, I'm looking at that pink 132 thing, right? All right, now, that's my line of sight. It's an imaginary line that is straight from my eyes horizontal, right? Means it's going to be parallel with what? The floor, right? Okay? So my line of sight is parallel with the floor of the ground. Imagine that imaginary line there, okay? See it in your mind's eye. If I look up to the top of the ceiling, then do you see the angle that is created right here? All right, so think. Angle of elevation. Okay, look at the picture at the bottom. Okay, so you're in that tower. Here is the line of sight. The line of sight for the people in the, what do you call those things? Watchtower, that sounds fine. Control towers, there you go. Those guys that are in that control tower, their line of sight is straight ahead. If they look up at the plane, that's their angle of elevation. And that just makes sense. But if I'm the pilot in the plane, his line of sight is here. This is the pilot's line of sight. And in order for him to look down towards the guys in the control tower, this angle 2 is the angle of depression. And that looking down, if you're depressed, you're down. Okay? So that ought to make sense to you. Go back up here. So that means that the point below the line, is that going to be the angle of elevation or depression? Angle of depression. Okay? Now, the process is not going to change, folks. We're still dealing with some old horse called a horse taking oats away. You need to be writing this down on your notes. I have no understanding of why you don't do this. If I print out your notes for you, makes no sense to me at all. Look at this. So I'm looking at angle 1. It says classify each angle as an angle of elevation or an angle of depression. So here's the fella. His line of sight is here. He's looking up towards the plane. Is angle 1 an angle of elevation or depression? Elevation. Angle of elevation. There's the same guy on a cliff looking down towards the boat. What is angle 2? That's the angle of depression. Angle of depression. It's looking downward. Now, I want you to notice something about these pictures. You have the line of sight. You have the ground, floor, whatever. We've already determined that they are what kind of lines? They're parallel lines. When I throw a line of sight, an angle, it's a transversal. which is creating what kind of angles right here? Congruent. Why? What? It's that zigzag again. Okay? These angles, if you remember, and you need to write this down, are alternate interior angles, which are congruent. That's going to be very, 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 very important to you. Please write this down. I'm not putting this up here for my health. If I were, I would be much skinnier, and I would be much more energetic. If I just did. Yeah, I am pretty energetic. Can you imagine what I would? Oh, Lord, have mercy. And this could definitely happen. If you're on the top of that mountain, looking towards the fella or the girl right here, whatever, not real sure. You got to figure out what angle 1 is. If you are the girl looking up towards the mountain, figure out what angle 2 is. The girl looking down towards the river, figure out what angle 3 is. And then if you are a fish looking up at the girl, yes. If you're a fish in the river or a scuba diver in the bottom of the river, looking up at the girl trying to say, please help me. I want you to put angle of elevation, angle of depression for 1, 2, 3, and 4. What y'all get for angle 1?
Elevation.
You get depression. That's the angle of depression. It's not the elevation, though. Because the elevation is going to be this girl's line of sight here, looking up towards that mountain top.
But I thought like somebody sitting on top of the mountain is looking straight across it.
That's their line of sight.
Yeah, elevation.
No, that's just their line of sight. Elevation is from the line of sight up. You got it backwards. So number 2, this girl's line of sight, she's looking up towards the mountain. This is your angle of elevation here. And her looking down towards the river is what? Angle of depression. And then the fish in the river looking up at the girl, thank you, Maddie, is the angle of elevation. Please fix this in your notes. Okay? The dotted line is the line of sight. The line of sight for the fish.
So the one going like this.
No, it creates, this right here is the angle. Well, this is the angle. This is just a line where they're looking. Okay? Your line of sight is if you're standing, your line of sight's always parallel to the floor or the ground. Okay? Because if I'm standing upright and I'm looking straight across, this is my line of sight. When I raise my head to look into the sky, that angle that is created between my line of sight, which is always the same, because think, your line of sight's always going to be the same because you're the same height all the time, right? So my line of sight's here. If I look into the sky, then the angle that I have created by lifting my eyes, this angle right here is my line of angle of elevation. If I look down at the ground, from my line of sight down, it's going to be the angle of depression.
So they're talking elevation? I mean line of sight?
Line of sight for mountaintop. Whoever's on the mountaintop. Right? That's the line of sight for the mountaintop. And then the one in the middle is whose line of sight? That hiker's, that girl, whatever. Right? Got to be able to know that. And know also that what can you tell me about angles 1 and 2? They're congruent. Angles 1 and 2 are congruent. The angle of depression and the angle of elevation are going to always be congruent. Angles 3 and 4 are also congruent because they are alternate interior angles. This is going back and getting information from first semester, okay, about October of first semester, maybe end of September. So remember that. Angle of elevation and angle of depression are always congruent to one another. So look at this problem. All right, you know the Seattle Space Needle, right? Okay, well, you need to look it up sometime, not in this class. The one in Seattle, the Space Needle in Seattle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? This is all here for you. There is no guesswork here. All you're told to find is why. Folks, do I even need the word problem to be able to solve this? Please don't. No. You don't even need, because you're going to do the same thing as you did yesterday. Y is the opposite side because I'm going to circle 70, right? So I've got my hypotenuse. Y is the opposite. 67 is the what? Adjacent. What do I know absolutely nothing about? I don't know anything about the hypotenuse. Some old horse caught a horse taking oats away. I don't know anything about hypotenuse. Oh, I guess I'm going to have to use tangent. Tangent of who? Tangent of 70 over who? Is equal to what?
Y over 60.
Right on. Y'all agree with that? Isn't this the same thing we've been doing all week? Okay. So now we're going to cross multiply. Y times 1 is y. Tangent of 70 times 67. Let's see here. Put this in your calculator because it said to round to the nearest what? Yeah, round to the nearest meter. So we're rounding to the nearest whole number. Okay? So I've got tangent of 70 times 67. I hope you're writing this down because I'm going to tell you what, I'm not going to have any mercy on you, no sympathy for you if you do not understand this material. 0. 184 meters. Does that make sense? Yeah, it does because this needle thing is way, 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 way. It's like one of the tallest structures in Seattle. Okay? And why then is this shadow so small? Who cares? It's in meters. I don't even care. We're not even going to worry about that. It's probably going to be about, well, if that's meters, and a meter stick's a little bit longer than a yardstick, right? So how many feet? Take 184 and multiply it by 3, and it'll give you about how many feet tall it is. See what it is. I don't know. Over 500. Pretty tall. Really, really tall. Meters. Okay, so it's almost 2 football fields long because a football field's 100 yards, right? I don't know. Is that right? Okay, so that's almost 2 football fields tall. Pretty tall. Okay? Look at the next one. Oh, that is beautiful. This is gorgeous. You like the picture in your notes? Zoe, are you feeling a little like I'm taking away your thunder with your drawings? Yeah. It is so the Titanic. Yes, absolutely. Let's don't, because this is math. Here we go. I don't provide the picture, so it's color time. Here we go. All right, so it says if the ship's captain looks up to the top of the house. So here's what you need to do. Where's his line of sight? Because here he is. He's the king of the world. Isn't that what they say? He did. I think he did it again. I made him do it. Nothing. Don't worry about it. Just making it up, Cody. All right, here we go. No. Where's his line of sight? Right here. It's about the bottom window, okay? That's his line of sight. But he is looking up to the top of the lighthouse. So, boom, there it is. What kind of triangle has been formed? No. Listen to what I'm asking. Mm-mm. Right triangle. There we go. Because there's my right angle. Okay? There's my right angle. Now it says, if the ship's captain looks up to the top of the lighthouse at an angle of 12 degrees, where does the 12 go? Where the person is, 12 degrees. Because his line of sight up to the top creates that angle of 12 degrees. And it says the lighthouse is 142 feet tall. We don't know anything about the hypotenuse. What are we trying to find? It says how far away is the ship from the lighthouse. Where am I going to put my X? Is it going to be on the bottom of that triangle or the hypotenuse of that triangle? The bottom. Now, I want to just run this by you, okay? Anytime you're trying to find a distance should always be the shortest way to your item. Now, what's the shortest way from here at the front of my room to my desk? Straight. But I could go all the way over there near the windows and then make a loop and go to my desk, right? But the shortest way would be if I were to walk straight towards my desk, and if I did, this line that I'm walking in is going to create what kind of angle with my desk? It's going to create that right angle. So it's always a perpendicular distance. The height, 142 feet, is going to be perpendicular to the base of my triangle. Now we label it. Yes, let's get moving. Circle your triangle. Thank you. 12 degrees, circle it. We got hypotenuse. 142 is the what? Opposite. X is the adjacent, isn't it? Right? All right, come over here. Some old horse. Car. What do we know nothing about? We don't know crap about the hypotenuse. Boom, boom. Yes, Speedy McFreedy. I know. Tangent of 12, bless you, over 1 is equal to, what's the opposite over the hypotenuse? That's a lie. Opposite over adjacent. Right on. And then, folks, it's just cross multiplying like normal. Okay? Yep, it's going to be word problems, but they're easy. With pictures. Oh, my God, they rock.
In the book, they ain't gonna do it.
So, what are you going to do? Okay. You do it every day in this class. Check this out. I don't know. I'm gonna. Does it tell you in the problem? Then you have to write it all out. Just kidding. 142 divided by. Y'all just collectively went, 668. All right, so let's just round to the nearest whole number. 668 meters or feet? It is feet. So what's that mean, 668 feet? What's 668 feet? The ship to the lighthouse, right on? Facile, difficile. So is this any different than what we've been doing? Nope. There is no catch. No catch. Look how beautiful. Fireworks, isn't it lovely? All right, let me ask you something. Where's the height of the fireworks? The height. Look, boom. Maddie just went just like this. She went boom, boom, boom. She drew straight down. That's the height, because when you guys go to the doctor and they check your height, do you do this? Let's think about this. Hold on, nurse. Hold on, nursey. Wait a minute. Hold on. Do you do this? Check my height now. Who? Please tell me somebody that wants to be shorter. Really? For real? I do not believe that. If you're tall, are you not like glad that you can kind of peep over top of everybody else? They could have seen the daggone fight. Oh, Lord have mercy. Here we go. Hey, la 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 la. Here we go. All right, and so they're enjoying the picnic, right? And they're looking up at the fireworks.
Where the guy is.
The guy is. She's looking straight at him. That's right. She's like, hello, darling. They are sitting 100 feet away from the launching pad. Where's 100 going to go? The bottom. That's fine.
And then the angle is.
Okay, y'all just do this problem because I ain't going to talk you through it. Pardon me? No, not necessarily. Not necessarily. Don't just automatically assume that it's going to always be tangent. Lisa walks 15 feet from the base of the tree. She measures an angle of elevation from the ground to the nest, 62 degrees. Find how high the nest is above the ground. Bless you. Where is my X? Is it the tree or the hypotenuse? Bless you. It's the tree. And again, what are we going to have to use? Tangent of 62 over 1 is equal to x over 15. How many of you had that proportion? Rock on. Here we go. Tangent of 62 times 15 is equal to 1. And you get x to be approximately how much? 28 feet. I'm hoping y'all are right. Yep. How many of you had 28 feet? High five. Boom. And the last one. Oh. She measures an angle of elevation to the bird of 67 degrees. Where did we put 67 degrees? 67. 15 feet. How high the mother bird is above the ground. And again, we use tangent of 67. X over 15. When I cross multiply tangent of 67 times 15, we get x is approximately how much? 35 feet. Does that make sense? Yeah, if she looks at one limb above, then that needs to be higher than the answer you got in the last one, right? All right, so here we go. On page 547. You need to do 1 through 8, and you're going to have to draw number 8. Okay? Now, when you see 1 through 6, you're going to be like, oh, all right. 7's given to you. 1 through 6 is the angle of elevation, angle of depression. Big old deal.
What do you mean?
Number 7, the picture's given to you. No,
She wouldn't do that.
No.
She didn't mean to.
No, I didn't mean to.
Can I go pull up my notes?
Yeah. And then, folks, on page 549, I want you to do 41 through 43. This is going over the altitude and the leg theorems. Suck it up, do